So I got some air tools on clearance at the local auto parts store, and I need a compressor that can run that. So let's see if I have enough bits and pieces laying around here to assemble a working compressor. All right, so this already had the oil drained out of it. I put in a little over a quart of 30 weight. Some of it was non-detergent, some of it might have been detergent, whoops. And I ran out of 30 weight, that's all I had. So I did the rest, another almost a quart of Dexron 6. I just went through my selection of ATFs and whatever I had, you know, the most of that I thought I would use the least of, I shoved in here. ATF, of course, is hydraulic oil. Shouldn't have some of the detergents that motor oil has, so just to try to, you know, avoid detergents. And then because the ATF is a little bit thinner, I added some of the Technolucas. And so that should increase the average viscosity, because it is hot out here. You know, if you're in a cold climate, you could probably run straight ATF in this, but because we're so friggin' hot, I want to increase that viscosity a little bit. The Techno says it's good for manual transmissions, so maybe it's good for air compressors, I don't know. So it even has a tank on there. This thing's kind of haphazardly welded into place. You might be able to see. Yeah, not really bolted. So this was, at one point, it had an engine on here. I think I have a valve for an engine that, you know, increases and lowers the throttle. There's a very special valve, it's all pneumatic, that you need to control this system, but I can't be bothered. So I'm going to make it electric. So now all we need is an electric motor. Ooh! I don't know if this works. I've never turned it on. I paid like $3 for this at the scrapyard. It rotates, so more than likely we can make this work. So let's see what it wants. Well, I threw a cord on it. It turns over free. This appears to be a kind of a paper board wrapped capacitor from, like, I want to say the 1930s. So I'm just going to plug it in and see what happens. I accidentally broke one of the supports. That was kind of dumb of me. So at some point I'll have to see about replacing it. It should spin okay with only the 3, but I'm going to cycle power. We're going to start with the switch on the motor off, just to make sure it doesn't blow up just from the cord being connected. All right, I cycled power. Nobody died. Now we're going to turn the switch on. Okay. Well, that appears to work perfectly. Well, it was spinning the wrong direction, because of course you want the fan on the compressor to blow that way. Otherwise, I think the compressor's non-directional. But just these two, you know, kind of off-center 11/16 nuts, take them off. I don't see smoke, do I? Yeah, anyway, reverse those 2 wires, reverses the direction. Easy. Well, what would you know? This piece in my hand appears to be the only piece I have that'll fit this air compressor, but color me surprised, I have something that fits it at all. I didn't think I'd have anything in this particular size. Then I got one of these down here. So that's going to be from an NPT to a, I want to call it a compression fitting, single flare. Anyway, it just so happens I have this from... That was actually one time on an air compressor on the one side. It has this size of the single flare, and on the other side the single flare is nutted to an NPT that just happens to be the same size as that hole. Now, is that hole a little bit small? Yeah, probably yes. However, this was on an air compressor, so I mean it's what we got. So what I'm going to do is I'm going to blowtorch this copper here. I'm going to try to anneal it so it's nice and soft so I don't break it, and I'll try to bend it into a shape that fits. And of course you want to leave that coil because that'll help cool it off, so that'd be nice. Hear that? Oh, the pressure's leaking by the rings. I need a check valve. This motor is rated at 3/4 of a horsepower. Probably in modern ratings it'd be 2 or 3 horsepower. Now this compressor wants 5 horsepower to drive it. Might be able to see there. So of course that makes sense. That motor would start it and it would get up to about 100 psi before it would stall. So that's more in line with half as much power as I need, as opposed to 1/6 the power that I need. Right around the 80s they changed the rating on the motors. Anyway, this one is 18 amps, so yeah, this I guess won't run on a standard breaker, but it's probably 15 billion horsepower. yeah, it's 1 1/2 horsepower, but at 120 it's 18 amps, so that's going to be a little bit more. So that should be right around in line with our 5 horsepower. It's 1700 RPM. Now this compressor, I think it says it can run up to maximum of 1050. Of course, with our pulley setup, we're going to be getting a lot less than 1000 probably, but of course ideally what we want is the absolute fastest we can possibly get this compressor to spin with the amount of horsepower available. This is probably enough power. I could probably justify a bigger pulley, but yeah, with any luck you'll be able to read the pressure gauge here. Full scale is 100. It is made of plastic. Hmm. $35 microfarads. All right, like 200 microfarads. Now we're going to see, and I think I already know the answer, if this will start with pressure on it. Like a 91 or 2 psi, we're going to see if it'll start. Yeah, so this pressure gauge came with the 3 compressors that I got, and the 3 compressors, 3 tanks, no motors on any of them, and of course so I saved that, and it threads right into this. A buddy of mine has another compressor that's bad, so he has a couple of 2 identical ones. So one is for parts, so I got this pressure switch here, and then it's actually live right now, so I shouldn't get my fingers in there. So it'll be interesting to see what pressure this shuts off at based on the setting on this switch, and I don't know if I'll be able to change it because it's a security bit, and I don't know if I have a security bit, but we'll see. We'll see what happens. I shut it off real quick. The air tools I got, they recommend a line pressure of 90 psi. I have this gauge in here that peaks at 100. So of course what I want to do now is I want to adjust this so that this little plastic gauge doesn't explode. I have other gauges, but I like this one because it's full travel is 100. That means I get a little bit more detail, whereas if I use something else where it was 0 to 100 over here, I wouldn't be able to see a lot of detail. So I can get within a couple of psi on this one. So I'm going to adjust this pressure regulator down to where it's at 90 or 95 or 100 or something. Well, this pressure regulator doesn't work. You see the end broke off when I tried to adjust it. Tried lubricating it. I tried welding the jam nut that was on there to use that as leverage. I couldn't adjust it, and it doesn't seem like it regulates pressure at all, like it's maxed out or something. So that'll need replaced. I got like 4 of these. 3 of them are identical. One of them is same shit, different brand. So we'll stick that in its place. Next, I got it all wired up, and I got our jumbo gauge here. Now the pressure blow-off valve there is 150 psi. Now my tools recommend 90 psi. So what I would like ideally is for them to always have 90 psi. So the tank pressure must be higher than 90 when the compressor kicks on. That way the line pressure that's regulated, you know, is always 90 as this cycles on and off. It never goes below 90, so my tool never slows down. Of course, now this tank here, it actually says max working pressure 120, factory settings 90 to 120. That's weak. This thing is 150 psi, or excuse me, 145 psi maximum. Of course, yeah, 150 there on the blow-off valve, all that fun stuff. So what I ended up doing is I got a pair of needle nose pliers, and there's a security bit in this switch there, and I cranked it up so it kicks on right around 100 psi, and then there's a certain duty cycle, so therefore it kicks off at like 145. So it's exceeding the working pressure of the tank by a little bit. This blow-off valve still isn't quite blowing off. I've tried it. It still has some spring to it before it kicks, and then I'm still right at the bleeding edge of this compressor. So, Now this capacitor, I have phone video I'll stick in here. Oh, it's buried in the trash here somewhere. God, I don't know if I showed you this on camera. 189 to 227 microfarad. It's a range, so nobody knows what the capacity of this is. Now you see right there, 250 volts AC, 60 hertz. So it's probably, this is a start capacitor, and I think this is wired as run because it's kind of hooked up all the time. But you see it pissed out the electrolyte. It made a huge mess. There's still goo on the underside of this. Yeah, you probably can't see that little smear in there. So I ordered biggest one I could kind of easily find. I didn't look too hard. Was a one just like this. It was 100 microfarad, and I believe it was listed as a run capacitor. So I wanted to make sure I didn't fall short. Now I have this hooked up here. So let's see. This one is 20 microfarads plus 15 microfarads. So that's what, 35 plus. This one actually smeared off. We'll say 30. So 65 microfarads. And the one I'm getting is 100. And this just barely starts with these three capacitors. If it's under pressure, it actually won't start. I have to kick the pulley, and then it goes just fine. So the 100 microfarad should be just about right. But this is just for testing. So anyway, yeah, switches on, switches off. That's all well and good. Put a pressure regulator on it. Once the capacitor arrives, I think it's approaching done. Yeah, these are some of the leftovers I'm going to have from this project. This isn't even including a lot of the leftover brass bits I've gotten from all three of these compressors. For example, this guy I haven't used, but this came from the compressor selection, so I have spare parts in addition to selling two of these. So this compressor and this tank were effectively free, plus all these things are effectively free because I sold the other two for roughly what I paid. I'm going to end up using one of these, but it doesn't seem like much, but something like this, it cost you, I don't know, $8. This thing, $4, it's probably $5, $10, and there's a couple of things, right? So for example, right now, I need a part. I need a reducer to reducerate this even further, okay? So come over here. First I go into the steel bucket, because these are my least favorite. So I have one of these two, right? These are reducers, both the same outer diameter, different inner diameters. I believe this is the correct one. Come over here, and you notice even this nipple, I reused that. You can probably see there are a little bit of teeth marks in it from the pipe wrench, words, but this will probably thread in here, and I bet you the outer diameter, this will fit that. We'll have to take it apart, but I'm pretty confident. So, boom, I saved myself, this isn't much, this is, $3 I saved myself, just right there, saved myself another, $2 there, and I don't have to go to the store. So, I'm in the shop, I haven't walked outside, I haven't gone anywhere, I have all the parts that I need. Saves me time, saves me effort, saves me driving, and it saves me money. And you'd be surprised, this thing, when I was assembling it, I had this laying around, this copper. I don't know how much you'd pay for that, right? This was on the copper. This I needed. I had it in one of my drawers. This I needed. I had one in my drawers. I had this. I can't believe I had something that threaded onto here. That's genuinely unbelievable to me. Here's the thing, right? So this, if I didn't have this, how would I figure out what thread that is? I can't very well carry this tank, which is welded, by the way, not bolted, welded to this air compressor. I can't just carry both of these into a hardware store, at least not without considerable effort. So how in the am I going to find what thread this is, right? Because I don't think that's a pipe thread. I could be wrong. And it's possible this is a pipe thread and I've mated two things that don't fit, but they don't leak. So that's good enough. So I would almost have to go to the hardware store, buy something, take it home, and trial and error until this fit. I saved myself all that time. I found this part within, I would say within about 30 seconds of looking for something that fit that thread. It's probably the only one that I have in that thread. I probably don't have another one, but I found it within 30 seconds because I've organized all of my pipes. This down here, this reducer, I had in a drawer. So by the time this is over, I could have spent 50, 80 bucks on, little bullshit, right? So this belt, I had this belt laying around. I barely had a belt that fit because it seems like all of mine, this is one of the longest ones I had, and all of mine were just a hair short. So, and you can look over here and see, that's the belt section. So I just looked basically for the longest belts in the section, and I just picked them and I was playing with them until I found one that fit. I got over here. This is the iron, so it's different from the steel bin. This is the either galvanized or black cast iron, so this is the soft iron bin. And then some of this is the brass section. These are my rags. These are socks that are worn out. Super handy just having a, jeez. Super handy just, if I get greasy on my hands, if I get greasy on something, I want to wipe it off. I have shop towels. Those cost money, but I have regular paper towels too. But sometimes you want something really substantial. For example, if I'm leaving something in the weather and I have some sort of opening and I don't want rainwater to get in there, you can shove a sock in there or something, or to keep dust out maybe. It would be a better, because the sock will get saturated with rain, but this will, you can stuff it in there, keep dust out. Sometimes you want something more substantial. Those are free. Some of this brass is mine and some of it I inherited. So it's a 50-50 mix. I'm going to show you the brass section. You're here watching me assemble an air compressor out of scrap. Obviously you want to see the brass section, so I'll show you how I have this sorted, because this has a very particular sorting to it. This is garden hose thread only. So any object that has a garden hose thread on it. Okay, so this one, you notice, has a pipe thread and a garden hose thread. So there's two different threads, but because it contains at least one garden hose specific thread, it goes in this bin. So this bin contains only garden hose stuff. So this is the valve section. So a bunch of these are the valves that I inherited that are barb fitting, and then I just have various, some of these are pipe thread. I think actually almost all of these are pipe thread, but they're valves, basically. Easy. This is pneumatic specific. So something that would basically only be used for air. So this this came with those 3 compressors that I got with the 3 tanks. This is a very particular valve. This is when you have a gas engine running a compressor. So what this does, this is your outlet. This will go to your carburetor, and this is the manual set. And so yeah, this is your compressor and this is your tank. So, okay, compressor compresses air, shoves it into the tank, right? Your engine is running. Now there is, I believe, 0 psi at this, so your engine is revving. It's at, high RPM. This outlet vent here is plugged, and this is normally, it's going to be, you have this little piece disengaged when you're starting the engine so that there's not pressure on the compressor. So you'll engage this just like that, boom, and now you're compressing. Okay, so what happens is when the tank reaches the proper pressure, normally the engines are pull start. You don't have an electric starter, so you can't just shut it off and restart it and shut it off like you would an electric motor. It's not so simple. So what happens is when this reaches the proper pressure, when actually the pressure is set right here with, there should be jam nuts. It sets the distance here and the spring preload. Pressure is reached. It shuts off the tank. The tank is sealed. It holds the air in the tank. Boom, that done. Now the compressor is still spinning, right? So it's always going to be spinning because the engine is always running. The engine doesn't shut off. So it simultaneously vents the compressor. So this valve opens, it's open to atmosphere, and the compressor just pisses out. And then I believe, I'm not as certain about this, so don't quote me so hard, but I believe this one is given tank pressure. So the pressure goes through a little line over to your engine, and it actuates a little pneumatic solenoid, and it lowers the RPM of the engine. So the engine idles down, and then and it vents, and it runs for a little while, and then you use the air pressure, and so then punk, and it shuts this, opens this, shuts that off, engine revs, and it starts compressing into the tank again. And then if you want to, for example, if you want to manually shut off, you can hit this and the engine will idle down, and no matter the tank pressure, it'll vent the compressor. And then also when you're starting, you want to shut this off so you're not also cranking the compressor. You see the premise. Anyway, this is a one-way check valve. This is going to be, that's what that other piece is I showed you. The premise, you see that check valve right there. The premise is that the tank pressure is stopped by the check valve. It does not go back into the compressor. The purpose of that is if the tank pressure was on the compressor, the only thing stopping it from leaking to atmosphere is there's the check valve in here on the one side, and then the rings of the compressor. And generally that doesn't work very well. Before I had this check valve on here, you could hear out the vent, the crankcase vent, a little bit of a and so, yeah, the air was leaking past this reed valve and past the rings. It's just a reed valve. It's only designed for when it's running. It's not really designed to hold pressure. So this large check valve is more for holding the tank pressure, when the compressor's off and stopping it from pissing out. It doesn't work very well. It's old and dirty, but it's a slight improvement. This is another one, anyway. You know what most of these are, just air fittings. Now this one is from an old truck. This is for the air brake. So this thing, oh boy. Normally, yes, so normally this top piece is down into the valve, and if you pull it out, it springs back. You actually have to have pressure built in your tank, and then you can pull this out, and then it'll stay out because the tank pressure holds it in the outward position, and then it allows air to go to one of these hoses to relieve the air brake. So if for any reason you have an emergency, you can hit this inwards. It's real easy to hit, and it hits the emergency brake. Or, for example, if you lose pressure for some reason, of course, a loss of pressure also doesn't hold the air brake, or excuse me, the parking brake disengaged. So theoretically, if the pressure gets low enough, it'll engage the parking brake. But this is supposed to actuate first, so that when the pressure gets a little bit low, this will actually, it won't have enough pressure to hold this out anymore, and the spring will clunk, move it back in. And one of these is a vent. So tank, brake, vent. And so when this goes clunk back in, the parking brake will vent to atmosphere, and then it'll grab, and it'll stop the truck very quick. This is for the heavy duty trucks. You know what I mean. Okay, this one is propane. Let's see, I think this is propane specific. And it's different. The propane is different from argon. I think that the threads are generally different. This is the older style, so this would have been like 20, maybe 30 years ago. The seal was on this piece. This is obsolete. This is when the regulation changed and you had to get the new propane tanks. They use this style where the rubber seal is built into the valve on the propane tank. It's supposed to be, I don't know. I'm not, of course I don't know a huge amount about it, but it's safer, seals better. You get the premise. Now this one is hose barb. So anything, it's the same rule as the garden hose. Anything with a hose barb on it, one or more. So some of these, there might be a T, or for example, this one's both hose barbs, but anything with at least one hose barb on it. So of course, National Pipe Thread and hose barb. Now these this is anything with at least one compression fitting on it. I want to call these compression fittings because there's actually a different type of compression fitting. That's like a flare compression. But anyway, I think these are generally referred to as compression. And you've seen these before. These are on, for example, if you have a swamp cooler. These are the other type of compression. So for example, this one would work with a single flare copper and then a line fitting, and then it crushes that single flare copper, you know, over this little taper there. Now this one, it's designed, I believe, there should be, oh, I can show you. So this one is a female, and so it would fit a male, something like this. Of course, that's not quite the same, but you see the premise. So this is the other flare compression. These are all, I think these are called compression too, or some sort of compression. I don't know. Somebody will correct me in the comments. Who knows? And then this one is for NPT only. So all of these fittings have pipe thread, only pipe thread, nothing but pipe thread, no other threads. Then we got our top shelf here, and I filled it with a little bit of clutter. Would you look at that? So this, for example, is just a gigantor valve that I didn't have space for. That's a pressure gauge. Now some of these up here are mystery. So for example, this is going to be probably an argon gas. This one, I don't even know, because of course it has the hose barb on it, but I didn't put it in the hose barb section because it's a very specific thread that might almost be like the same thread as the R12 or something. This one, what was this one? I couldn't figure out what this one is. I think one of these, it's an adapter from pipe thread to not pipe thread. This one, yeah, this one's the mystery. That's why it's in the mystery bin. I think this is pipe thread on both sides, but it was just weird, so I put it up here. That one's another probably. Oh, this is going to be some sort of breather, I think. Gravity. Oh no, this is maybe a pressure blow off. So the gravity holds that down. When the pressure gets high, it blows off. Something of that nature. This one just had damaged threads, so I put up here because it can be soldered. This is another. I almost want to call this propane, but I don't think it is. Oh yeah, this one's just a really nice old valve. Isn't that pretty? It was just big. And then this one. See, and I think the reason I put this up here is I tried it and it wasn't an NPT, for example. Oh, and I had another one of these somewhere in a different drawer. Well, that's pretty inconsistent of me, isn't it? I guess I'd better put it in here, but I don't know what that is. Because one is, I think one is a right hand and one is a left hand. Let's see, that's a left hand. Oh, that's a left hand. I don't know. I don't know what that is. It has been 1 year and 2 months since the last video clips that you saw. Now you'll find that the shop looks completely different. You see, it's still a mess. It's just a mess now with different objects than last time. But anyway, we come over here to the light switch by the wall. I got this nice thick extension cord. Now there should be 20 amp service here to this outlet, I think, and that's a fairly thick looking extension cord. I've used this compressor quite a bit throughout the last year. It works really well. I cranked up the pressure to, let's see, boy, it's been 1 year, can I remember? The compressor, I think, is a maximum of 125 or something like that, and the tank is a maximum of 125. And so I think I pushed it to like, I think that's working pressure, 125, and I think I pushed it to like 130 or something, just so that when the compressor kicks on, the pressure is still high enough that the line pressure hasn't fallen. You know, the tank pressure is higher than what the regulator is set at, so that way you don't get the tool doesn't get slow, you know, or weaker before the compressor kicks on, because that's always annoying. The tank is fairly small, and it's handy because the compressor pumps up a little bit faster. You know, usually I only use it for a little bit, so I'll just plug it in, and then by the time I get, you know, set up and I'm ready to take some tires off, it's already come up to pressure, and so then and then I'm done and I shut it off. And it doesn't seem like it kicks on super often. Like I could probably do pretty well a whole tire, maybe 2 whole tires before the compressor actually kicks on. Something like that. It's not terrible. So super handy. Definitely, if you come across loose tanks, motors, and compressors, accumulate them and assemble yourself a compressor, because it's super handy to have. And I got all sorts of, you'll notice the air lines laying around, so I can get them kind of off into the distance. And it's great having an air tool, because I don't really have you know, any electric impacts I can use, and so having just an air impact is comparatively pretty cheap, and it's great to have some sort of impact. So obviously, if you're made of money, buy an electric one. But anyway, thank you for watching. Make sure you hit subscribe, and I will see you in the next episode.
Yeah, baby, yeah! There it is!
So this is super crazy dangerous. I think you need about 300 amps.
You riding this?
What the fuck is happening?
Balin said not to talk crap about this kernel. It's a piece of shit.
That right there is Balin Mania, and we are gonna do something really stupid today. This is a terrible idea. Balin might die.
This is so unbelievably sketchy.
That's the power of really old engineering.
Why must you put me through this, you jerk? Hey, aren't you the guy with the truck? Oh shit, the guy with the truck.
Not okay.
Make a wish, everyone.
Make a wish.
No, I'm not doing this.
No, go.
You went too far. Someone doesn't stop us. I have no faith in authority at all.
He's making me uncomfortable.
That shit burns well.
Yeah, it does. That's good tape. He's still looking at us. We should probably leave. Yeah, he is. He's intently staring at us. This guy, man. This guy.